Hello everyone, welcome to this exclusive webinar on GenAI and multi-agent workflows. I am Jaya Gupta and I'll walk you through the exclusive next generation multi-agent workflows and GenAI systems that are far beyond the basic prompt response models. Today, we are going to explore how GenAI has evolved from simple language models to autonomous agents, capable of reasoning, tool uses, decision making, and many more. So, let's start today's agenda where I'll cover the evolution of generative AI from transformers to agentic AI. Why RAGs, function calling, LangChain came into existence, what agent workflows look like with demo and along with the use case. Building agentic RAG systems with tool and memory. What are advanced orchestrations with LangGraph, QAI, and model context protocol, the fundamentals of all behind the scenes. And what will be the coming next technology which will shake the world and which will provide its feedback to the real world problems and projects. So let's start with first topic, that is the evolution of generative AI. So as you see here, we started in 2013 and where we were building the word embeddings. So you might have heard about the globe vectors, the word to vec encodings, the bag of words models, NERs, lexemes, right? So you have heard about these things. The goal at back that time was to learn semantic representations of the words via neural networks because we wanted our text to be trained using deep neural networks. So we were converting our text into a format of embeddings and finding the relationship between the similar kind of looking words, which may have the relationship between them, like king and queen, brother and sister, mother, father. So we were at that stage. And we were exploring how we can evolve this technology so that it can be trained using neural network. So this phase lasted till 2017, and in 2017, something incredible came up. So that was a paper called Attention is All You Need, the name of the paper. And that paper has introduced transformers in the era. Transformers handle long range dependencies with self attention mechanism. They are powerful enough to handle many things, right? They are the fundamental basis behind this chat GPT and large language models which are there in the industry. These transformers actually built over deep neural networks with positional encoding, and you can say in layman language like some heuristics which are embed into them to create something which can work with focus and attention. So it is able to find out the focus in a page, which lines are important, which paragraphs are important, or you may say which paragraphs kept your attention for some time. Like in a whole broad picture, there is a picture hanging on a wall. There are some parts of that picture which actually grab your attention. So transformer has that attention mechanism built into it. So that phase lasted till 2020, and after 2020 we started seeing some large language models. So first one was there, this chat GPT from OpenAI. And the goal of these large language models is to train massive general purpose LLMs on web scale data. So these LLMs evolved over that time of 2 years only. Think about it. So in the beginning, it was taking 4 years, then 3 years, then only 2 years to evolve such an incredible thing. Then following ChatGPT, there are several versions came up. And these large language models was using the mechanism of transformers. And they were trained massively on the web scale data, a large web data which we have, right? Suppose that there are multiple models coming up like Copilot, like Google Gemini, Gog, and many more, right? Then in 2022, there were some disadvantages, or you may say limitations, of those large language models. So industry started using those large language model in this era. I was working in a company and I faced that we were using this. Sorry, I actually used this model of Llama, right? So that was produced by or introduced by Facebook. So there were some problems in those models, like they need a lot of computing power along with that to run actually. And along with that, they were not precise. They were not giving very good results while giving a small prompt. So after that, this few shot prompting, zero shot prompting, right? So these kinds of prompting mechanisms came up. Even the models were large to download on your system, eating a lot of memory of your computer. So their quantized versions came up. But still, there were limitations. So what was those limitations we'll talk about in our coming slides. So due to those limitations, RAG came up because these large language models cannot utilize the database we have backend in our backends. So RAG were the systems which can select the items from storage or your database based on the requirements of the customer, right? So RAG are able to provide us a better managed flow of information into the LangChain system. This LangChain is actually using the large language models and working on a chain of thought mechanism, right? RAGs are retrieval augmented generation. It means they do something, they prepare some things like chunking, embeddings, and all, and then they do retrieve them and provide only a little context to large language models because they are not able to handle the rapid customer queries these large language models previously. So this has evolved in 1 year only. This is astonishing. From 2022 to 2023, we see the RAG came up, it came into existence and adapted by the industry, academicians, researchers all over the world. Then at the end of 2023, we start having this buzz of agentic AI amalgamated with LangChain. So goal of this particular fundamental is to make large language models more autonomous, interactive, and tool using agents. So we'll see our case study and that will help us to understand this. How they are fulfilling this goal. Then in the last year, like we are in 2025, nowadays you see on LinkedIn a lot of hype of multi-agent systems, right? So till yet we were working on single agents with LangChain, with RAGs, with function calling, tool usages, many concepts in the GenAI era. And nowadays we are talking about model context protocols, which are providing a more better orchestration, management, memory update, context switching policies. So they are able to coordinate with multiple agents with memory, planning, and collaboration. So without a further ado, let's walk you through to our case study, which help you to understand what were the limitations and advantages of different models and techniques which are evolving over the years. So case study says that we'll we will be able to talk about, we are going to talk about customer support automation for an e-commerce company, right? What is this customer support automation for an e-commerce company? It means we are using it every day. We are purchasing any item from internet, from an e-commerce company like Amazon, Flipkart, Meesho, many are there. And then we are facing some issues in our order. Maybe order is not arrived on the time, or there's some defects. So we want to launch our complaints, we want refunds, we want exchanges, right? So many things. And we also want an email or SMS on our mobile phones that so and so activity is going on, and we want to track it properly. So this use case will be able to tell you about all the technical things which has evolved, and with the help of this we'll see it. So let's first see what is the goal of these autonomous uh, customer support systems. So basically we are looking a goal where we automatically answer customer queries using AI, covering orders, returns, refunds, and product information from 1000 plus SKUs and support policies. So let's keep this goal in mind, and let's see our attempts, what we are trying to do to fulfill this goal. So in the first stage, we first started with transformers and prompting, which were there in the era of 2017. So we did an attempt to load a pre-trained LLM model like GPT-3 or any other open source model like Falcon, Py 3, or any other model like Claude, Llama. And then we'll write a prompt like answer the following customer queries based on this context. The prompt is like, what is the return policy for shoes bought during the sale? Right? So depending upon this prompt, we wanted a satisfying answer. But what happened, we hit some limitation that LLM doesn't know what your policies are unless you paste them in the prompt. And if you paste them in the prompt, there is one problem that these pre-trained models have some token limits. And these token limits are exhausted. What are the token limits? Basically, they can handle those many tokens for input and output. There is a complete range of it, right? So if you don't know your policies and you paste them in the prompt, then prompt is so long. Then the answer is short. So we are not able to get the proper answer. So due to the embedding of these policies, they eat all the token limit. So I've faced this in one of our case studies, or one of our use cases which we were building in the industry. If we were writing a large prompt, we are getting a shorter answer. Then there is a problem of hallucinations. Model complexity gives wrong return answers. So every time you run it, it is confidently giving you the wrong answer. It cannot remember the past conversation context or customer information. So then we realized that we need a way to bring my business knowledge into the system dynamically. So to do that, we started with RAG. So in the second attempt, we added RAG. And what RAG did, there is this life cycle of RAG, you can say. We first extract our data, we chunk it, we embed that data that supports the documents, SKUs, our order policies, and many things. Then this embed data is stored into a vector database. So this is a pre-processing of all that thing which we were doing in the transformer. We were just directly pasting our prompt in the LangChain environment for the LLM to answer previously. But now what we are doing a preparation first. And then we are retrieving the top three chunks and passing those chunks only to the LLM along with our question. So it is able to find out the right match to the user query properly. And the answer is more elaborative and understanding and near to our information. So if you write the prompt like return policy for shoes during sale, then it takes up the query, it retrieves the top chunks, it provides that to LLM, and then LLM can summarize those answers and provide you the result. It can generate the result for you. So in the coming videos, we will see the implementations of them one by one. Then here we got some results which were a bit satisfying, like the answers are grounded up in actual policy documents and it can handle the questions about specific products as well. Right? It means it can handle the question like what was the policy going on when we have purchased the shoes and in that sale. And it can handle the question about specific products like shoes, t-shirts, bag, and many more. But here, still, we were having some limitations that it cannot do multi-hop reasoning, like track my order and provide me the refund policy and give me the refund so and so many days. It cannot perform the action like check order status and create return. Still, there was lack in the memory that each query is treated statistically. There is no connection between different queries which user is asking. It is not able to take the whole previous context properly. And also, there is no way to handle customer history. It means you cannot personalize response or adjust tone over time for different users or customers, depending upon what they are asked in the past. So, we again had the self-realization that I need the model to take decisions, use APIs, and plan responses. So we need something better now. So what we did is to introduce a function calling with LangChain agents. With OpenAI, the same concept is called function calling, but for open source model, we can say we are using the tool and the agents framework. So we have exposed get order status, create return, and calculate refund as functions. We have used OpenAI's function calling or LangChain's tool plus agentic framework, which let the LLM decide when to call which tool based on the user intent. It means now we will be able to get two things working, like what was the price of my order, track my order, and provide me the refund, like this. So many queries in one sentence. So let's see, was it able to handle this limitation which we were having previously? Now it can handle where is my order? So and so SKU is with order ID. Agent called the tracking API. And if the user say refund me for that order, agent calls the refund policy tools. So it can do the interfacing with APIs and can do the function calling or tool calling. Still, there were new pain surface areas like complex workflows fail, like check order, return, send SMS. This can't be planned very well. And there are multi-agent workflows which are still not supported. Memory gets messy, multiple agents or tools cannot share the structured memory easily. It is hard to audit what happened. Because tools are called, but there is not a full trace available how decisions are made by LLMs, RAGs, tools, and function calling pipeline. So still these were the pain areas. Now what happened? We again had a self-realization that we need orchestration, we need memory, we need collaboration, and need a proper structure to place everything properly which is functioning and working. In the stage 4, in the era we are living right now, we are using model context protocols. So they are able to handle this collaboration and structure along with the memory update properly. With MCP, and to create multiple agents, we need Trio AI or AutoGen or LangGraph. So what we do here, we design a multi-agent system where we have user interface agent, which parses customer queries. Like every work is assigned to different agent. We have a retriever agent which uses RAG. There is an executor agent which performs function calling. There is a memory agent which maintains sessions and preferences. And we use model context protocol to pass structured context to all of them, like task ID, user ID, previous tools called, retrieve documents, function calling results, etc., etc. So MCP is making a collaboration of different agents which are working autonomously for different user prospects. Now, it has fulfilled the goal which we have visioned in the beginning. Like, it can do the full workflows with the prompt like return shoes which I bought on the sale last week and send me the confirmation. So it understands the intent, retrieve the sale specific policy, it calls the functions, related functions, and sends the SMS and logs all over the planning in the context memory. Everything in the context memory properly. And we have some additional wins with MCPs, like they are traceable, auditable, and providing everything in the agent steps properly with persistent memory across sessions. Right? So we have different sessions going on, still the memory is persistent. Multiple agents with division of roles, as we have seen in our use case. Still, may think there might be some limitations to MCP. Yes, you are right. MCP is not the full-fledged solution to our problems. And we will see what may be the limitations of MCP, and due to them, the further technologies are evolving. So this era is evolving so fast. If you won't upgrade yourself, you lose the race. And let's see the whole picture, what we have covered till yet, that MCPs are able to handle the domain knowledge where transformers were not able to handle it. Even RAG and function calling did handle the domain knowledge. Then what about real-time business actions? MCP is able to handle it, whereas transformer were not, RAGs were not, but function calling did. Then it can handle workflows which were not handled by any of them properly. Then what about multi-agent collaboration? MCP can do it. Memory across sessions can be done by MCP, not by others. Reliable, grounded answers can be provided by RAG, function calling, and MCP. Why? Because they are taking up your whole documents and policies and database. And then what about tool uses? So tool uses fundamentally came with function calling. So it was not there before it. So RAGs and transformer were not able to use any tool because this was not a mechanism there. MCP is able to do it all. But let's see what may be the pain areas of MCPs which is coming or which is there in the market, and people are now talking it very slowly, right? But still, they're building something over it. There are some design problems, like no single protocol or schema or standard is there. What about complexity? High engineering and agents design effort is required by the engineers. So this is the basically a skill which companies are looking into the engineers, that they are able to do high engineering and agent designing efforts. they can do it. Then latency and memory bloat in large workflows. Means it is taking a lot of time to give you the answer. Then coordination. They still need human guidance in many cases for the coordination, like what to do next. No standard for role-based access or context filtering. So this is maybe one thing over that industry folks are thinking and they're building something new. Lack of robust simulation or test tooling. They're also difficult to explain or debug workflows to business users. It's still tricky how to explain it to the layman's or to the users which are using these technologies. So, what we be building after this, which can provide a better human guidance for the coordination in case of multi agent workflows, are reinforcement learning from human feedback. So, this is currently going in the industry, and people are trying to amalgate this concept with multi agent RAG flows, MCPs, autogen, and QAI. So, in the further videos, let's see the implementation from that era to this era and further. So, thank you for listening me. Stay tuned. If you like this video, please subscribe my channel and always keep updated. Thank you. Thanks a lot.